Justin is an associate professor at the Faculty of Environmental Studies at York University. His research focuses on landscape ecology and geographic information systems and has been published in ecological modeling, ecological applications, and environmetrics, among other journals. Welcome, Justin.
So, thank you all. Thank you for coming, and thank you for this amazing weekend. I've gotten a great deal out of being here, and I appreciate that you're all still here. So what I'm talking about today is spatial analysis of human-wildlife encounters in the Greater Toronto Area. Some of you have seen some or much of this in the past year, but there's a couple of things going on. One is we've recently got Tracy on the team, so I'm also introducing the analysis, and Tracy's going to go into more detail. And the other benefit of having Tracy on the team is she redid some of the visuals, and the maps look a lot better without taking anything away from all the previous amazing students that are named on the slide. Joyce, Will, Jacob, Wanda, and also Xiaotian or Tracy. So a whole group of students that we started working on this like more or less right when the project started. And I would come to U of T, and we'd meet in the evenings, and we'd work on these maps and these analyses. And of course, this was all under Sue Reddick's project here, and this with co-investigators Sue Bunce and Lisa Fawcett, and this particular workshop, of course, is funded by SSHRC, so we give them their due. So this presentation is about mapping human-wildlife encounters in the city, so I'm going to talk about, it basically goes in three parts. The first part I'm talking about describing the encounter, what an encounter means. Then we're going to do mapping of the encounters, and then we're going to talk a bit about how we can try to explain the encounters. And as I said, some of you have seen this before, partly because it's your data. So Brad, Gates Wildlife provided half of our data, and the Toronto Wildlife Centre provided essentially the other half. So let's start with describing encounters. So encounter data, so if I was presenting this to ecologists, this is what I try to make sure is clear. This is not ecological data that's collected for trying to count populations or understand how many animals are present in a region. It's a different kind of data. It's not population data, but I would argue that it can tell us things if we are listening. So this is a lot of what we're trying to do, is we're trying to look into data sets that were not necessarily collected for the purpose that we're trying to analyze them for. And we're trying to learn about wildlife in the city through encounters. So again, GTA, Namrata just took you through what the GTA is. This is a little map of the GTA. Includes both the city and the suburbs, and that will become interesting when I talk about some of the encounters and some of what's gone on. So for an encounter to occur, you don't just have the animal, you have to have the human and the animal, and then you have to have the human reporting it afterwards. So this is, again, a different type of data. There may be encounters that are not recorded because nobody made the call, and there may be animals that are not encountered because nobody encountered them. So those are things to keep in mind as we go through this analysis. And so what is the call? The nature of the call also matters. People are calling the Toronto Wildlife Centre, asking them to rescue an animal. People are calling Gates, asking Gates first to get rid of the animal, and then making sure that Gates is not going to harm the animal, as he told us earlier. So we looked at 6 years of encounters. There were 28,000 plus encounters in our Toronto Wildlife Center database and 81,000 plus in our Gates Wildlife database. And the first thing we do, we obviously they didn't give us the data that specified people's names and addresses. They gave us data that had that information stripped out. We further anonymized it to the intersection, and then Tracy actually did some work to re-randomize them around the intersection so that we're not clustering everything on a small number of intersections. So one initial thing as we go through this exploration of the data is you're looking at this chart, and on one hand you have the Gates data, and on the other hand you have the Wildlife Center data, and you can see a difference in the species that are represented, right? So this again is something to tell you the nature of the encounter. Presumably, these organizations are both operating in the same city, where the same numbers of these species, the population of the species is the same, but Gates is encountering, close to 2,000 raccoons, whereas the Wildlife Center is low hundreds, close to 2,000 squirrels, and the Wildlife Center is 300-400. So, whereas on the other hand, look at the Wildlife Center and birds, you're close to 2,000 a year, and Gates is from 300 to 500 a year. So this is already telling you something about what kinds of encounters the different organizations are seeing in their work. And so when you're trying to learn something about the nature of encounters, there's a clue there. So our whole point was to look at encounters. Our initial question was actually one that was brought up by Gail, I think, yesterday, which is, where are there more encounters? Are there more encounters where there are more people, or are there more encounters where there are fewer people? So now we get into the second part of the talk, which is about mapping encounters. So here we have the human population in the Greater Toronto Area. So if you can see that there's this kind of nose, it's like a colored nose, and that's the downtown core, and that there's this concentration of human population in that part of the city. So watch that space. Stay tuned and keep your eyes on that space as we go forward. So here's raccoon encounters from the Gates data set in the GTA, and you can see there are some areas in the outer suburbs, in the outer GTA that are dense for encounters with raccoons, but there's also a real concentration in the downtown area. So this is just a histogram that Tracy did of the raccoon count per census tract. So we're just looking at the frequency distribution of the counts. Here's raccoon encounters normalized by hectare, right? Normalized per unit area. So now, if you're looking at these outer areas that had those high numbers of raccoon encounters, now we see that those were actually because there's a lot of land. And as you look at the encounter density, the numbers of encounters per unit area, now you're really focused on the city. So the number of encounters in a given area is higher in the areas of denser human population. This is a histogram of the same phenomenon. So notice that in the earlier one, it was more of a gradual, heavy-tailed kind of distribution, and this is a fairly rapid fall from a initially high value. So now we get into another issue, which is raccoons per person or per 100 people. And now again, we have the same concentration in the city, but again, some of those outer suburban areas have lit up. They're dark. There's something going on there, and we've asked, maybe Brad, you can give us some of your explanations, because we didn't know what was going on. We had to ask Brad about that when we visited. So raccoons per 100 people, and these are the histograms for that. So let's now look at the same data in a different way. So we've mapped it, but now let's, what I call explaining these encounters. There's a few other ways that we've looked at the data to start to understand it. So one of them is, look just again with these histograms. This is actually a histogram by species, and I got one of our students, an undergrad student, who's now at the School of Public Health actually, but she was a stats, it was Wanda, and I got her to do this. Like, we got this idea, like, why don't we take a look at the distribution of population by species. So we were looking over areas, but what about by species? And then you see this phenomenon, which is, you know, you could argue it's a heavy tail, but this is because it's a log. We've already taken a log of the data. I don't know if this is, I don't know how many people know what that means, but the point is, most encounters are with a small number of species. So this is something that's intuitive. If you're in the city, you probably see a lot of squirrels, a lot of birds, sometimes raccoons, but there are many other species that are encountered. As you can see, that list goes on and on and on. And they're down at the other end of it, at the far, your right, at the far right end of it, from your perspective, there's some fairly interesting and rare species that you'll see. So, and that's like, this is the Toronto Wildlife Center data that we're mapping, or that we're looking at here. This is the hotline data, which, as Natalie mentioned yesterday, is the kind of the flagship program of the Wildlife Center. So these are people that are calling, and these are the species that are represented in those data. So another way to look at it, we looked at it over space, but we can also look at the data over time. And most of these, this is again raccoons, but many species show this, a very strong seasonality. And there are, again, two reasons, hard to decompose. One is the rhythms of the species themselves. Their breeding patterns and foraging patterns are very seasonal. It's a seasonal climate, so the species adapt. And then in terms of encounters, it also stands to reason that there will be more encounters because there are more people outside to have them. So strongly seasonal. When you look at the time series, you can see there's the trend and the random at the bottom, and then the seasonal is the third from the top. So that's, you know, a very strong seasonal component. So, what drives encounters? Well, the number of wild species matters, but most of the encounters are with a small number of species. Most of the encounters are in the summer, which I at first thought was mainly because more people were outdoors, but after talking to Aaron and, well, especially Aaron, I learned a little bit more about the biological rhythms of the animals, and that would also be influencing the seasonality. We were talking about, the different types of species depend on the type of data set And that does suggest that human attitude is driving the encounter, but attitude is defined in a fairly broad way here. It's really like your orientation. So it's not necessarily, a positive or a negative attitude, so much as, what is the structure and the nature of the encounter in the city? Am I encountering an injured animal? Am I encountering an animal in my home? And that is the driver of what kind of encounter you have, is your own, institutional position, where the animal is. I mean, this is the type of conversation we've all been having all weekend. There are more encounters in higher density areas, even when you normalize for density. And that's true of almost all species. There were a few species like rabbits and foxes that we've flagged for further study because they are the opposite of that trend. So there are more encounters with rabbits in the outer areas where there are fewer people, and more encounters with foxes in the outer areas where there are fewer people. So that's interesting. I want to look at that a little bit more. I want to look at that data a little bit more. We're going to put some students on that before we really make any more firm conclusions. Not that there are very firm conclusions anywhere in any of what we've done so far. But I do think one fairly tentative conclusion that I would make is that we are the ones driving the urban wildlife encounter, and that does fit with what the City of Toronto's recent report on the topic. Just wanted to acknowledge Joanna and the report that the city has recently put out. And so that is kind of the point that I would end on. Humans are driving human-wildlife encounters in the city, and I did want to share this cartoon in case you all didn't see it, but it's definitely my favorite one on the green bin issue, where they've got a laser beam, and this is the next step. Build a better raccoon bin, and they'll come back with a laser beam. So encounter data tells us about the relationships, but ultimately what we gather about wildlife will also tell us about ourselves. I think that's probably the most profound implication of all this, and really, I think that's the point of getting us back to the conversation on design and on habitecture is, if it's our behavior and our design that are driving these encounters, then that means we can consciously design the kinds of encounters that are most favorable to us and to the other species, I hope. Okay, that's all.
Thank you, Justin. So the floor is now open for questions.
Right away.
All right.
Cool stuff. I'm curious, so we're defining encounters, which I like, just the kind of the alien connotation. Encounters and this very close encounters. As you're saying, there's a requisite of having a human report it. And I'm wondering if you're exploring options where you don't need the person, like wildlife cams, other sort of sensors. Are you, is there a plan afoot to track any of these guys with other sort of radio collars or chip implant? I mean, like, are you using technology or is there an interest in using technology to further enlarge a data set?
Well, it would be, so for me, that would mean different data sets. Mm-hmm. But I do think if we're going to stick to the encounter type of data, there are other ways that we are working on. I don't know whether I want to. Are you going to say anything about it, or should I? Okay. So in that case, we do have an idea of people being able to, take a picture.
Right. Upload, create an app.
Yeah. So that is one of the areas where we want to go. That'll still be a person reporting it, but it could also be it'll be a different kind of encounter again, right? It'll be more like a leisure or like a fun encounter that you're just reporting, because it's not like trying to help an animal or trying to get rid of an animal. So I think that could potentially have a completely different pattern. Or maybe not. It might have the exact same pattern because people will be snapping pictures where they are and most of them are downtown. So who knows?
Great talk, Justin. And I'm hoping that you're going to further incorporate some of the city data into your mapping. And I think you won't find too many surprises. Another thing I would recommend is our wildlife, our coyote map that we have on our website, that you self-reported sightings of coyotes, and that's something that you can map as well. I wonder if you're going to be exploring the possibility of overlapping this data with some data on built form in the city of Toronto. I think that will produce some really interesting, maybe not only built form, but perhaps some of the landscape data as well, to sort of look at, how these encounters are sort of facilitated by those natural and built forms.
And the bird strike data are in here. So the bird data are driven by these bird strikes, and that's where all the tall buildings are. And so that is, we did actually try to do some of that. We found a model of the building heights, and we were trying to see what we could do. And beyond like the totally obvious, there are more bird strikes where there are tall buildings, we weren't able to really, there were no surprises, so we didn't end up going further down that route. But there are some other interesting correlations that Tracy will be actually talking about next. So.
Two things. First, I guess I don't understand. Did you account for or the idea that depending on the location, people's own experience or attitudes with animals might change the relative rate at which they'd be likely to call about it and make an encounter official? Like I'm imagining in rural areas, people might have different sets of experience which would lead them maybe to not call or something. Yeah. And related to that, I'm wondering if the Gates company is already, if it's homogeneously distributed in terms of its clientele anyways. And then the second question is, I'm wondering about, because I'm kind of a layman with quantitative data, so I'm just trying to figure it out. There was the first map where you showed density by region, not by area, unit area, right? Not this one.
The first one.
The very first one. From my own point of view, I don't see the point of that map, because to me it's like, I just want you to tell me what information I'm supposed to get from this.
It's just raw.
Oh, so it is.
We're just taking the data and mapping it.
All right.
That's it. Yeah.
So, all right. So the point is that the next one is the informative.
It's and
then the second, but the second one is the logarithmic histogram, which to me seems like by making it a log, it's like you've added analysis or processing to it, but then you've obscured the relationship of the fact that these ones are so.
There's not much to look at if it's not a log graph.
Because it would be like that?
Yeah. Yeah.
Okay, all right, because I just don't know anything about this, so that's what I'm just asking, just trying to figure it out.
What was your first questions were interesting. So about the distribution of the clientele, I don't know. I don't know. Maybe Brad can answer that. I actually had an implicit assumption that there was a fairly even distribution across the GTA. If I'm wrong about that, that would be interesting to know. But we don't have some strong. Certainly there was no strong bias in the data to suggest that there was some kind of a. Only people in Scarborough call Gates.
There are the three variables that I see that play out are certain municipalities refer us, and we have been for years. So that might, I think one of your slides there shows Brampton as
it's really this one.
That's
The
Brampton, right? Up in the left? Yeah, so they refer us and have for quite some time. We advertise slightly different in different municipalities, but sometimes it's cheaper for us to advertise large in, like, back in the Yellow Pages, which was still in effect, to half that data, or a little bit more than half that data. So when you have, the way the Yellow Pages works is, depending on population density, they charge more in the GTA because you're serving more clients. They're getting more books distributed than they would, say, in Brampton. So I think overall the ads fluctuate more or less the same size, slight differences maybe. And also we have less competition in the more rural areas than we do in say Toronto, where back in those days we probably had maybe 30 or 40 companies competing. In Brampton, we may have 10 or 12. So we're likely to get, in certain municipalities, the lion's share of the business. And I think that's it. So less competition in some territories. Advertising can fluctuate, and the municipalities refer us to the three variables as I see them.
Yeah. But again, to me, this doesn't look, to my eyes and whatever stats we've done, this doesn't look like there's some kind of regional bias. The other question about the possible bias in the calls between rural and urban, that could be, yeah. But I mean, there's a rural, I also think there's a rural-urban difference in encounters anyway, but people not calling would certainly be reflected in that.
Could you just go forward to your final slide?
My final one. Sure.
So you've got human, I mean, I'm sort of approaching this from a social science perspective, and you've got humans are driving wildlife encounters in the city, but would your databases allow you to say something more specifically about which humans are doing this? I mean, they're anonymized, I guess, for confidentiality reasons, but yeah, I guess you could break it down by gender or by age or even socioeconomic status.
Well, what we did was we took the data and we overlaid with the census tracts.
Right.
So whatever characteristics the census tracts have are available to us. And the census tracts, what was it, from 2006 are pretty good, and in 2016 they'll be pretty good. In between, there were some issues, which I'll spare you, but.
So when you overlay, do you get a sense that in certain places with higher economic status, people are more likely to report, or areas with different ethnic groups are more likely to report, or is that within the...
I didn't do that. I didn't do that, but we could. We certainly could, and that might be an interesting thing to do. I thought of humans as just a species. I was just looking at these, this species and then all the other ones.
Hi, I was just wondering if you were planning on or thinking about differentiating positive versus negative encounters to find maybe areas where people have good encounters with animals, enjoy it, and maybe find hot spots where, say, raccoons attack people, like Mr. Owens would
like
call
the mayor, like the former mayor. Okay, so yes, it is something we want to do, and there is a student that's looking specifically in the notes of the Toronto Wildlife Center data, because that's where there's a lot of interesting stuff going on, but it's not, there's a lot more work we have to do before we can start to map that, because it's like keywords and reading paragraphs and paragraphs of notes for tens of thousands of encounters. But I believe there's a lot in there. So I wanna look at like particular species and get somebody to read all the notes for a few species and start to see what's going on. I got a bunch of ideas after Natalie's presentation yesterday. Like, she was talking about the green roofs. So if we could just do a keyword search on green roofs under duck species, we might find interesting stuff or be able to classify by the type of problem. So yeah, within to look for that kind of thing, we're going to have to get into the notes, but we want to do that.
So we have time for about 1 or 2 questions.
Thank you, Justin. Great talk. I'm not sure if I can frame this right, but we're counting this as urban, rural, but there's kind of an interesting suburban aspect to it, and I just wonder, are you planning on kind of teasing that out? And not just related to population density, but if you think about design, how design of suburbs might be different versus urban.
Well, that's a great thought too, and I was thinking about it when you were presenting, Sarah, because Sarah was presenting these kind of suburban interventions, but then they would have to be different in an urban context, right? So, this is the GTA, which most of which land area-wise is suburban. And I admit, like especially now, and I was thinking about this over the whole weekend, is that I have an urban bias. I've been analyzing this with a very urban bias, because I've been trying to I've been sort of saying, there's Toronto and then there's everything else. And so as I was saying about Toronto, and so I do think if I do step back and look at it, from a different, analyze it in terms of suburbs, analyze it in terms of of variables from the census tracts, we might find other interesting stuff in there. So I already have three more things to do. Tracy, are you taking notes?
Just to help you with that,
Okay,
again, the city commissioned Ipsos Reid to do a survey of a representative sample of Torontonians about their encounters with wildlife. And that survey will break it down based on age, based on location in the city. We found that Scarborough tends to have the most negative encounters with wildlife, and you can see how that's defined. Again, they do a really good job. Majority, 50% of the people in the survey lived in houses. They didn't own their own houses. The other are apartment buildings, because that's another, but a huge group of Torontonians. So I think the evidence there will be really interesting for these inquiries. And again, it's in the report the city came up with last year. It's online.
So there's no excuse.
There's no excuse.
For not reading it.
It's appendix 1 of the
So
report.
if there's somebody who's a wildlife researcher in Toronto, there's absolutely no excuse for not having read this last year.
The reason why I'm
Is that
promoting
fair to
it,
say?
that's why I'm saying it. And two, because I wasn't able to use it for any policy direction yet, but it's such a valuable piece of information that I think it would be great if others could use it. Because I was like, what do I do with this? Scarborough needs more education? I don't know. But these are things that, that I think would be really interesting for this conversation from a social scientist kind of point of view.
Okay, we'll just take one last question.
I just kind of had a small comment. When I was thinking about this, I was wondering about using maybe social media data to see about people tweeting about wildlife in Toronto or Instagramming or Facebook and whatever. I know that you could easily get that from Twitter, but I don't know if you have locations of things. But I've noticed that people tend to tweet actually at the Toronto Wildlife Center.
Yeah.
Like when there was the raccoon in the subway the other day, it was on every form of social media that I'm on by multiple people. So maybe that would just demonstrate more positive interactions with wildlife too, not necessarily just people who are having problems or finding dead or injured wildlife.
Yeah, I mean, it's one thing that I've thought about a lot is, and who was it? I think it was Marcus this morning was talking about different platforms and like an open source one and proprietary ones, and those are all like really interesting decisions that we're thinking about right now. It's like whether we're going to use Instagram or Twitter and Instagram or something, or try to roll our own or roll one that interfaces with these, because it's like trying to get people to install a new app is already a big barrier, and so it might be better to try to use behavior that people are already doing.
Yeah, I wonder if you could find ones that have already been tweeted or whatever, right?
Mm-hmm.
Yeah, no, there are ways to search Twitter going back. There are things, there's definitely like projects